I'm making a game that teaches calculus. The game uses puzzles to teach the player about one of the core concepts of calculus, the derivative. If you want to try it for yourself, you can play the game right now in the browser at fluxionum.com. Games can be really good at teaching things. Puzzle games in particular are good at teaching the player systems of rules and how to reason within them. Good puzzle games start with simple logical rules and build up to more challenging problems. Solving a puzzle in these games is very similar to solving a math problem. So what if the underlying structure of a game was calculus? What would a puzzle look like? To show you the design that I came up with, here's a level from the second section of the game, Quadratic Planet. In this level, you can move the sliders on the graph, which sets the slope of the line on the left. The goal is to hit all of the square targets with the line. The solution to this puzzle is to set the slopes to -2, -1, 0, and then 1. In this puzzle, we haven't done any calculus yet, but notice the pattern here. All of the sliders ended up in a straight line. In the next level, we add more sliders. You can solve this puzzle by going from left to right and setting each slider so that the line hits the next target. Again, notice that all of the sliders end up in a straight line. The graph on the right is a discrete approximation of the derivative of the graph on the left. The function on the left is approximately y equals x squared over 2, except that it's made of straight lines instead of a smooth curve. And the function on the right is approximately y equals x, but it's constant on every interval. The more sliders we add, the clearer the shapes become, and the closer we get to the continuous version. In the discrete version, you can still see the general shapes. It shows that the derivative of a u-shaped function is a straight line. So let's add even more sliders. It becomes a little bit tedious to set them all manually. And from the last two levels, we can guess that the solution will be to put the sliders along a straight line, on the line y equals x. So we can set the function by grabbing the block labeled x and dropping it here. You can also use these sliders to set the slope and y-intercept of the line. Later on in the game, we introduce blocks for a variety of different functions, like e to the x, sine, and cosine. The blocks can attach to each other to form nested functions. I'll show you one more puzzle because this is one of my favorites. We start out with a simple looking puzzle with two grids like before. The twist is that when you move the slider, the target moves with it. In the next puzzle, we have 4 sliders, and again, the targets move to the same values as the sliders. We set the first to 1, the second to 2, then 4, and then 8. Did you catch the pattern there? In the next puzzle, you set the base of an exponent, and we can see that the pattern was the powers of 2. Now we double the number of sliders. And it looks like it's increasing faster than before. So let's set the base of the exponent to see what it is now. Next, we add so many sliders that it looks kind of like a smooth line. 2.3 doesn't work. Neither does 2.5. But 2.7 does. The number that we are approaching is e. From the simple rule that targets are the same value as sliders, we have discovered the fact that e to the x is its own derivative. There are a bunch of variations on this type of puzzle. Like, what if it's the velocity of a ship? Or the number of cells in a petri dish? Or, what if instead of moving sliders, you have to draw your function? The goal of the game isn't to replace a whole calculus class. For one thing, the game doesn't cover enough concepts to do so. But it could be a good primer and give the students some intuition for the derivative. That way, when they see derivative rules like x squared or e to the x, they don't just memorize the rules. They have some sense of why those rules are reasonable. I'm not finished with the game, and I need your help with playtesting it. Are you a calculus student? A math teacher? Do you like puzzle games? Go play the game and let me know what you think. I need your feedback to help figure out what things work and what things don't. Go give it a try. The game is called Fluxionum, after the Latin title for Newton's method of fluxions. It runs in the browser at fluxionum.com. The first section is Linear Planet, so click Learn, and then click on the first level. Once you finish those puzzles, you can try Practice Mode, which generates derivatives for you to solve, or you can move on to Quadratic Planet. Then, when you have some feedback, click on the link here on the main menu.